Go on. Who's in there?
How you going, guys? Curtis from Cutting Edge Engineering. Today we have in a center shift cylinder rod off an 18M grader that, as you can see, it is broken. The center shift cylinder is mounted to the drawbar and the saddle of the grader, and it is used to move the entire blade assembly to the left or the right and reposition the saddle so the blade can be moved all the way out to one side. Then the blade can be used to cut a wall or a batter or get close to an obstacle. And that helps to make graders a very versatile machine. But all of the forces that are generated by the grading operation are transferred back through the entire blade assembly, and if they hit something very hard or something that doesn't move, all that energy gets transferred into the cylinder rod, and that's why they break. So today we're going to be machining up a new rod, but the first thing we need to do is remove the ball socket off the end of the old one. And to do that, I'm going to be setting it up in the lathe. That is by far the quickest method to machine the weld prep and the spigot to align the end into the new rod, rather than cut it off in the bandsaw and set it up in a 4-jaw to machine the end anyway. And to machine it, I'm going to be using a 12mm button insert on our shop-made holder, so I've got enough clearance around the rod end. But first, I'm going to put a center drill in the end so I can align it later on. I'm going to be machining the spigot to 20mm, and that is about 1/3 of the diameter of the rod. So I've got that machine to size, now I'm going to part it off. With that parted off, we're just going to give it a quick clean in our parts washer. So this isn't the typical eye that you would see on the end of a dozer or a excavator cylinder rod. This is a ball socket and it has a trunnion ball that sits in this, and then a cap is bolted on the other side, and this style gives the cylinder maximum maneuverability over other styles of cylinder rods. So that's our end prepped, now we can machine up the new rod. And the material we're going to be using is 2.5 inch induction hardened chrome bar. Because this is induction hardened, I'm going to start with a ceramic insert. I'm going to face the induction area and then put a chamfer on it. Now I can change to my carbide insert and face the end of the rod. Now I need to drill and tap the end for the bolt that holds the piston on. And to drill it, I'm going to use a 26.5mm U-drill. And the tap I'm using is a Goering M30 spiral tap. These are perfect for blind holes because as it's cutting, it pulls the swarf out of the hole, and that way the swarf doesn't get packed in the bottom of the hole, causing a tap to break. I'm just going to use my belt linen shirt to remove the edge off the bottom of that chamfer so it doesn't rip a seal. So that's this end done. Now we can flip it over and machine the other end and drill the hole for the spigot. As you can see, that is running spot on. I know there are a lot of people out there that say you shouldn't use a 3-jaw chuck, you should be using a 4-jaw because they are more accurate, but these Gator chucks are very accurate straight out of the box. This one actually came on the lathe and I have done nothing to it. But if you're having problems with your 3-jaw chuck being accurate, I would start by completely cleaning it out, all of the mating surfaces, and you may have to machine the chuck jaws to true it in. But this is more than acceptable and I don't have to waste time with a 4-jaw. So we do have our own data on how long this cylinder rod is supposed to be, but it is always good practice to double check them to make sure there hasn't been any changes throughout the series of the machines. Same as the other end, we're going to start with our ceramic insert to remove the induction layer. I'm going to machine across 25mm, 10mm of that is excess material that will get machined off, and the other 15 will be for the weld prep. For our long-time viewers, you will notice I'm machining the induction layer at full depth, which I never used to do, but now we have discovered a new grade of insert with a new coating that can handle it. Now I can change out to my carbide insert and face the rod to length. To drill a hole for the spigot, I'm going to be using a 20mm cruz drill. Last thing we need to do is use a button insert to machine the weld prep. Righto guys, so that's our new rod machine. Now we can fit the rod end. And this is where drilling the center in the rod end comes in handy, because now I can use my tailstock and my center to push it into place. So that's measuring spot on, and I don't need to tack it because it's not that heavy. Now we can get this out and take it to the welding area and weld it up. George?
Are you George?
Yeah, you like George? Yeah, I like my George.
Hey? New George.
One more little bit.
Curtis and his Disney princess era again.
So we're going to set this up in our rotator. To protect the chrome from the chuck jaws, I'm going to be using aluminium flashing. I'm also going to use it to protect the other end from the weld spatter. I'm welding this with CIG Verticore 3XP, and backing that up is Argo Shield Heavy, which is 80% argon, 20% CO2. I'm running that at about 27 volts and 6 meters of wire a minute. Because this is a small rod, it doesn't dissipate the heat very quickly, so about halfway through the welding process I will reduce the weld volts and wire speed to limit the heat input, that way the puddle is more controllable. Something else you need to keep in mind when welding up rods on a rotator is the further you get out in diameter, the faster the surface speed is, so you may need to compensate for that by adjusting the rotation speed or adjusting the settings on your welder. Otherwise you could end up with weld penetration issues. Righto guys, that's all the welding completed and we've let that cool down enough. I'm just going to use the Y wheel on the grinder to remove some of this paint off the end. So that's this job completed. If you're wondering what happens with the old rod, it goes into our metal recycling bin along with all of our other scrap metal and gets sent overseas and recycled into something else. So this is a pretty quick and easy job for us. It's a couple of hours work and a couple of $100 in material. But if our customer was to buy this from the OEM, it'd be about $3,000. So this is a massive saving for our customer. That's it for this job. Thanks for watching. Righto, ready? The center shift cylinder is, oh fuck me. The center shift cylinder is, oh fuck me, I did it again. And the material we're going to be using is 2.5 inch induction homed. Righto. And it is used, I will turn the amps down just a little bit. Oh fuck. Off train. I can't even get words out.
Yep.
What was after that? And to machine it, I'm gonna set this up in our rotator and to project. We're gonna set this up in our rotator. And backing that up is Argo Shield. And backing that up is Argo Shield.
Heavy.
And backing that up is Argo Shield Universal.
Heavy.
I'm running that at about 27 volts. Right. Can I just start again?
No.
Please?
Okay. Like, what happened? What happened?
Stop.
Yep. What is going on?
Stopping on the bench.
Can you see it on? Like what?
You see, it starts cutting and it goes out, then it turns
Yeah.
around.
Why? Who? What?
I'm gonna have to pull it off. Maybe this way.
Why get such a small roll? Where's your big cling wrap?
It'd be even harder to deal with.
Okay. For you.
I don't.
This is painful as. Oh my god.
Ready?
Take 2. Yep. Just stand it up. Why are you starting in the middle? Why not start at the bottom and go up?
It's fucking harder than it looks.
Cardboard through. There we go.